So you don't have to take pictures. I'm gonna release here in the GitHub repo whatever I'm gonna say and the full slides. So just keep note of that link and you're gonna be fine. So as you notice, I'm coming from Italy. I have such a strong Italian accent. Hopefully it's gonna be clear enough for you guys. I'm working for over 10 years to apply artificial intelligence for risk management and counterterrorism. And it's been a long journey to try to combine research and production and management. And there are some sort of dark forces that bring me in exploring some languages like Fortran and Lisp. So we got GoNam authors that moved from Fortran to Go, and I was moving for Go, my implementation, to Fortran. So that's something that's really going wrong with me. And that's also one of the reasons is I wanted to achieve raw performances. And that's part of my talk, right? So I would love to get Go as sort of raw performances like C, and I never get the opportunity. So I said, okay, you know what? I'm going to Fortran. And indeed, it's quite spectacular. So I feel actually very overwhelmed right now by all the movements on AI, right? And I mean, what is AI? It's not even clear what is the intelligence. So how can that be clear what is the artificial intelligence, right? But here we go. And I love riding the one wheel, which is not so important here, but you're going to discover it's going to be important. I love playing electric guitar. And you're going to understand in a second. So the key question of that talk is Go the go-to language for AI? And of course, in this journey, I collected my thoughts, my biases, but I would love to answer that questions altogether. And maybe it's worth it to rephrase that question with what are the use cases for Go in the evolving AI arena? So let's set the stage, right? So when today we talk about AI, we talk about transformers, which are not the robot that come in automotive, it's just a neural model. And we will discover what are the neural models. But are you familiar with ChatGPT? Okay, so yeah, thanks OpenAI. Otherwise, I had to explain somehow what are the chatbot and the GPT technologies. But when we talk about AI today, we talk about this enabling game-changing technology, the transformers, with the autopilot technologies, with the massive language models that we're going to discover in just a couple of seconds. And which you cannot just talk in natural language with machine, that we can also ask to write code for us. It's going to be really buggy, but still, I couldn't write my Fortran code without ChatGPT, honestly. So it was a combination of human-machine, I'm serious. And then we have machine creating, like DALL-E, creating pictures and videos. And now the idea is to get AI in a multimodal way, combining text, pictures, audio, et cetera, et cetera. And of course, we also have some issues, the deepfake technology, which are actually quite impossible for us humans to distinguish between human-generated content or a machine-generated content. My opinion is that most of the time, AI-generated content is better than human ones, on average, but that's my biased hypothesis. So what are the large language models? And I said neural, right? That today, we cannot detach the neural and language models. And large is just an adjective, right? Could be even smaller, and that's a trend. How can we run language models in our computers? And that's part of, can we run language models in Go, right? That's the point. And so large is just an adjective, as I said. And language models are so interesting as they perform tasks like summarization, sentiment analysis, coding, arithmetic, sort of reasoning, that's not true reasoning, but kind of, and the ability is to generalize, remember, and adapt themselves, right? And yeah, I get that strong. It's just that when I talk about language models, it's actually kind of complex topic because they learn also not just the language, but the knowledge, a sort of view of the world. And they would not remember perfectly because they need to generalize. And that's why we get the hallucination. So now when we ask ChatGPT something, we get sometimes something good, sometimes something bad that might make no sense, not factual data. So that's an incredible amount of work right now in research on how to reduce hallucination. And my idea, I'm biased with myself, is it's just wrong. So with language models themselves, we're not going nowhere. But this is a very unpopular opinion. This is also quite interesting, though, that they can create those capabilities, which I'm a big fan of, just by learn to predict the next word at time. So when it's exactly when you see ChatGPT creating the answers for you, it's the same closer technology when you have WhatsApp or whatever, and you start writing a word, and you get suggestion, next words. So also that one is a language model. So we have neural architectures, learning, doing complex tasks just by observing natural language. The interesting part is that, by the way, that picture is being generated by DALL-E, right? So, and also the previous one, so that's kind of a powerful thing. So they cost millions, right? So to train models like GPT-4, I don't remember, I want to say something wrong, but I'm going to say maybe $63 million. So it's very impractical for us, no matter the language. Even though we can do that in Go, would we be able to afford just running, even though it's going to be Go? I don't think so, at least not me. And actually, we might want to fine-tune, and depending on the original model we want to fine-tune, maybe not 60 million, maybe 1 million, but still, it's kind of, or just $20. So it truly depends on the model we want to fine-tune, and we're going to get to the point. There are two phases, actually, in deep learning or machine learning, whatever, is the training and the inference. In the training phase is where we teach the model, right, performing something. And the inference stage requires significantly less computational power and just perform, just act, just perform the task. And there are already 90% of decrease of costs compared to just the former December, right? And there are techniques like quantization and other things that I'm not going to go deeper, that's going to help in the next future. So now we know that we have language models that cost a fortune to train them. How can we use that? So definitely with commercial options, OpenAI, it's going to be fine. But then we have Hugging Face, right? And Hugging Face, do you know Hugging Face, guys? OK, enough. So that's mainly the Python world, right? That's mainly Python community. However, they provide state-of-the-art software, state-of-the-art language models, state-of-the-art neural models, performing a multitude of tasks for natural language processing, text classification, token classification, what is a person, organization, and location in a text. Can you summarize the topic? Is my tweet positive, tweet or X, whatever, positive or negative, right? Et cetera, to audio, so text to speech, speech to text. So good job, Hugging Face. And here we got a benchmark of open source language models, just one actually, two, sorry, and the commercial language models. So GPT-4, I assume you are kind of familiar with that. And Meta recently probably a few months back, released Llama, double L, I can even pronounce that. And 70 billion parameters. It's huge, you cannot run in your machine, right? And they provide in different sizes. And what are the billion parameters? Gonam, the metrics, all right. So the largest number of parameters, the larger is the metrics. So it's just not physically fitting in your memory, right, in your RAM, or whatever computer you have. But the cool thing is Zephyr, sorry, I'm Italian, I cannot pronounce that. But it's just 7 billions, which is significantly lower than 70, and still provide good performances. Not in all tasks, like in math, reasoning, there's huge gap from open source models like Zephyr and GPT-4, for example, this is good enough for daily tasks. So, I mean, I'm not happy, right, with this slide. I'm truly not happy. I mean, and I should stop here. But AI arena is actually populated by Python softwares. Is that true? Well, Python is a glue language, right? So it's actually a lot of C library out there performing raw performances, scaling on GPU. But the thing is that people work on Python without thinking, right? So we have PyTorch, the framework to learn, right, on CPU and GPU seamless. It's amazing. And then we have even DSpeed from Microsoft, just a few examples. Is that Microsoft? Probably so. That would allow to distribute your training to tons of different servers and GPUs and TPUs. And then we have the transformer library from Hugging Face. And outlines, it's not that popular, but I'm going to use that example to do what we can do in Go. So when we got a language model so powerful, but we need somehow to constrain to guide the output generation. Let's say you want to create just a classification model, so positive or negative, right, from a tweet. Just want to perform sentiment analysis and keep your client happy. So you need to guide language model to constrain your output just in those two classes. And that's why we need some libraries. But there are an entire other family of language models or deep learning model that just imply, just classification models that by themselves. And you get positive, negative, no guidance, no artificial generations guidance required. And there's a word there. So how can we index content and search content from language models so that we can interact with our documents, emails, whatever, just by asking natural language, right? And it's going to be clear maybe a couple of slides more. The other part that it's very challenging for me is that is really raising the needs to run models fast and locally, right? So there's an increasing amount of open source projects enabled to run a 30 billion models language model just in your machine in an extremely fast fashion. There's Llama C++. And I'm not a big fan of having that much writing in my slides, but just to force us to reflect what we might even need to do to reach the same point. So there is, how can we scale matrix computations, just a multiplication, whatever it's going to be, to accelerated frameworks like Accelerate or make it working on instruction on 64 architecture, 32 architecture. I mean, that's a huge part, right? And how can we scale on GPUs and run on CUDA, on Metal, and how can we use an OpenCL backend for GPU? Then we get the Qdrant that nowadays is being promoted to be used by the X platform with a new language model by Elon Musk, probably it's called Gork, if I write that correctly, and would allow to store, that's going to be very unclear, sorry. So with deep neural network and language models, you can transform a text, a document, in a numerical representation. It's called an encoding, an embedding, right? And when you transform your text in an extremely long sequence of numbers, our dear float64 slice in Go, then you can do something. You can search. And you can apply cosine similarity. You can apply some similarity measures and actually do your search engine. And then we have Candle from Hugging Face in Rust. That's a sort of lightweight PyTorch environment. So also companies working for so long in Python, the trend is actually, I'm going to say move away, it's going to be possible, but still get a transition to a lightweight, less dependencies options. So coming to us, I mean, I wanted to rush because I couldn't stick anymore with Python and C++ and Rust, right? So, yeah, you can reach me and then we can talk about it. So, I mean, I probably don't even need to say that because if you are here, we all agree about the Go unique strengths, right? The simplicity. And I'm not saying negative way. It's not just simple. We could kind of complex stuff, I know. But it's a sort of seamless operation between human and Go, right? So you probably, I think we are all similar here, we spend the most time think about how we can find a solution to our problem rather than how can we implement that solution, right? It's going to be quite easier. And it's cross-platform, strong concurrency, stability, and maybe, I could just change the word, but the thing that we have maybe 0 dependencies. It's just something extremely satisfying, right? And that's a huge development interest. I don't know if any of you are interested in AI, just raise your hands. So I go, okay, no one, well, 2, 3, 4, we're kind of. So, and that's extremely good. So I hope at the end of this presentation to ask the same question and see all your hands, right? So I love you to understand that you can today use AI, natural language processing, those enabled technologies in your daily projects. It's nothing really fancy. It's something that you would understand end to end, right? Coming to AI with Go, there are a few options, maybe more, but those are the 3 that I like to highlight here. So one option is, why don't we just wrap existing LLM APIs or deep learning models or speech-to-text APIs and just wrap them. So the pros is, well, Go is almost made for that, right? Working in web and APIs, backend technologies, it's going to be easy. On the other side, we will always depend on third-party technologies. We need to be online, So there are cases where I just want to use my machine, even not connected to internet, right? So that's going to be an option for those cases, but for others. And I mean, there's no a better option, right? All the options are actually quite reliable. Then we have the C++ or Rust or C bindings to utilize the fastest LLM that can run locally in, just by Seago, for example. But then we got a problem about some latency on Seago, and we would never gain control of our applications. We cannot debug end to end, and we would never be able to optimize within our ecosystem. And the other, which is very challenging, is can we create algorithms and models, and I'm going to explain the difference in a second, just in pure Go, right? So not even touch Python or C, nothing like that, and just in pure Go. And of course, we have significant effort, and we need to be very clear and honest with ourselves. So is Go enabling run raw performances because of the garbage collector and other stuff? Maybe so. I haven't reached that point yet. So luckily, we have some sort of AI repositories. And I say AI like that because none of them is probably made to be true AI. It's just that are sort of fundamental frameworks or technologies that would enable somehow use AI. One of these is local AI, I discovered recently. It's again another Italian guy, so it's like extreme bias in Italy about AI technologies. And it wraps a lot of local and open source LLM, text-to-speech, speech-to-text, and expose them in a seamless API as OpenAI. So whoever uses OpenAI GPT commercially can just change the URL, but the API is going to be the same. It can use a local language model and perform in different performances, but the same thing as the remote one. Then we have LangChain. I should have gone deeper before, but I wanted to rush. Language models are nowadays used as agent. It's very complex. I'm going to skip that. So then we have GoNum. I know that they don't see GoNum as AI. It's very funny, but linear algebra, having matrices and performing very fast operations, is actually the backbone of AI. Right? It's everything about just linear algebra, more or less. Then we have from Gorgonia and tensors, and the main difference between those is that one stop at vector and matrices, and tensors are just infinite number of dimensions. And in machine learning, and I stop there, it's going to be quite necessary having that technology. Then we have Spago. I created Spago. I'm the main maintainer, and it drops a bit my contributions due to family and other stuff, and also some frustration I got, very honest with you, like what I'm doing with my long life quotes, what I cannot create, I would not understand. So I had to create deep learning models in order to understand. But is that truly useful, right? And Cybertron, again created by me and my little group, is powered by Spago, and enable using today natural language processing state-of-the-art in Go with 0 dependencies. And I'm going to have a few live demonstrations if I get time for that. So to introduce Spago, it looks like you are in a mathematical session, and so I'm going to be very, very quick. You can actually transform a mathematical equation in a pure Go code. You can do without Spago, but with Spago, you have something extremely cool for machine learning, and is transforming your operations in a computational graph. So what is the computational graph? It's a way to express in form of graphs, I would say, your operations, your inputs, and that's the machine learning. So at the end, the loss is, let's say I show you a banana, right, and an apple here. And I'm going to ask you, OK, what is that? You're going to say, so I bring you a banana and say, hey, no, and it's an apple. I say, no, fine, it's not an apple. And then we get the gradients, and we change the value of the matrix. Then again, I show a banana and say it's an apple. Say, no, come on. So it's an iterative process, right, until you get initially random weights, random numbers in your matrices, and the output of your function fits what you want. So very quickly, I just wanted to highlight that's on the right side, the PyTorch version of how to create a very simple neural model. And on the other side is the Go implementation with Spago. And it's very PyTorchish way to do in Spago. So you get your struct, just 2 parameters, which are just slightly overstructured from a matrix from GoNow, for example. And then you have the forward. And the forward is actually the flow of operations. And then you get for free the so-called backward, which is the training somehow. So what you can do with that, and AI is not language models, and neural networks is not language model, and all the combinations. So you remember that I told you that I'm a guitar player, just for fun. I never studied, but I love that. So how many guitar players I have here? At least 1, which is good. 2? OK. Well, I wish more, but let's say I'll just point to you guys. So let's say you love an amplifier. You have your favorite guitarist player, right? Mark Knopfler, for example. I don't know for Dire Straits. Anyway, they got the sounds that you love, right? And in pure Go, you can actually capture the sound of that amplifier and play just in Go, right, with the Go module, and simulate that sound. Just to give you an understanding, we have amplifiers that would cost 10,000 euros, $10,000, excuse me. And here you can capture the sound and get a really close approximation. That's how it works. And I'm not going to go deeper, because if we have more musicians here, I would have too. But just reach out to me in case, right? So let's go now to the Cybertron, which is the natural language processing in pure Go. I am so masked to be here. So now the system proposes as possible options to fill the gap, right? To fill the mask. Happy, glad, excited, blessed, likely, OK? So it's true, it's a language model running in Go. And I go very, very fast. The other that we have is question answering. So back then, before ChatGPT, there was a very powerful demonstration. Now we have generative AI that actually create content. Here's something different. Here in the question answering, and when I say question answering, it's simple as that. You create a document, for example, here's description of what is cloud computing, right? And we load the model, again, from Hugging Face repo locally or wherever. And then, in this case, for each single from the starting input, I just make one single function, extract answer. Can be easier than that. I get the context, the question, and the document, right? So now that I get there, let's see if I can find, OK. What are the benefits of cloud computing? And the system is actually able to extract from the original document the portion of text with start to end, so you can even highlight that if you like, the possible answers with a score. Last one I'm going to show here for question answering. Okay, sorry. It's, for example, what are the major providers for cloud computing services? And here you go. So AWS, Azure, and Google Cloud Platform. And the paragraph was actually quite long. So the system was able to extract that. And maybe something that I think is very cool is the zero-shot classification. So what the hell? So the zero-shot classification. And I said, when we have in machine learning, we need to train a model. We need to train our algorithm, right? And for a classification, I usually need a long list, thousands of records with an example of text and a class, sport, cinema, sex, movies, war, whatever. With this zero-shot, its name, where I can just write arbitrary categories, politics, business, science, technology, health, culture, sport, and then we can copy and paste text. That one, for example, where I said, new research shows that playing music can help you sleep better. And those are the categories ranked by likelihood and discourse. So that text is simultaneously science and also health in a way, right? Again, that was the text. And let me see if I have another second to show the one, which I think is kind of cool. This is the name entity recognition. And again, the type of structure is always the same. You load a task, and you just ask token classification to classify every single topic, every single token. And let me copy and paste from here. All right, so that is my text. The GopherConAU conference is taking place in Sydney, Australia. Then we have GopherCon Sydney as a location, Australia as a location. So you can truly use name entity recognition in pure Go running in milliseconds. I have a few more, but I don't get the time. So let's see if I get a few slides more. No, that was the backup plan. So let's wrap up a bit, right? So is Go the go-to language for AI? Again, it's a kind of biased opinion, but I say if we are Go developers, then yes, we can already today integrate machine learning, NLP technologies into our projects. If you are already in Rust or C++, there might be no point, right? You're already there, you're already close to meta performances. And well, if you're a Python lover, I don't know why you're here. That was. Thank you.